I'd like to welcome everybody to this 12th session of IBIU focusing on BIM case studies. We have it listed as case studies from IBI, but time permitting, there are some from outside that I'm going to want to touch upon as well. So same as always, we are accredited for 1 hour of structured learning with the AIA. If you're a member of the AIA, please put your AIA number in the question pane. Also recently, we've been asked to tell everyone that if you're a member of AIBC in British Columbia, please make note of that as well in the question pane. It just helps us to collate who the attendees are. So we're going to look at some projects from the 3 sectors of IBI, how BIM or aspects of BIM were used on those specific projects. The learning objectives to identify some practical examples of BIM within our firm, which we can then call upon for either proposals or feedback or subsequent work to learn from. Understand the difference between the types of BIM, building, civil, and plant focused, and what that means for those types of projects. Increase the awareness of our abilities to manipulate data, and empower us to imagine solutions for current and future projects. So as with always, we're going to start with a BIM recap. The definition, process involving the generation and management of digital representations of physical characteristics of places. That's all BIM is. Nothing about software. It's a process by which we're managing information throughout the life cycle of a project. That's the verb. The noun of BIM is the model or collection of models that we assemble, we author, we share, we manipulate, we review, we deliver, we use for subsequent generation of other information. And BIM can be applied scaled in any type of project, regardless whether it's building, linear, or a system. And that's critical, the scalability of BIM. And with BIM, two of the most important aspects are how we collaborate and how we plan. Previous sessions talked about both of these. Planning is so vehemently critical to know what we're doing. BIM, in a nutshell, is geometry plus data. Something with information about that something that gives you BIM. The degree of information is scaled depending on what you're BIMing, why you're BIMing it, and who you're BIMing it for. Our elements also have contextual relationships. So you may be modeling, in this example, the guardrail, part of the entity, part of the facility, which is the road, which is part of an overall complex network. So that geospatial integration of where things are in the physical world relative to each other. So rooms are beside each other within buildings, within sites, or geospatially within a GIS network scattered across coordinate infrastructure across the globe. We can manage life cycle information, and that's a matter of understanding what our assets are, what are we modeling, and where is all the information pertinent to that single asset, when is it going to come throughout the life cycle of a project, and how is it all coming together and being portrayed and delivered to the stakeholder or the consumer of the output. We talked previously about BIM uses. So every project you would define a BIM goal, whether it's these typical ones, the orange. We're going to make our drawings and schedules more efficiently. We're going to be able to review and understand and decision make our designs, and then form a basis for subsequent visualization, be it whether it's simple visualization or advanced specialized visualization. There's typical uses, so you hear always clash detecting, schedule simulation, cost estimation, etc. Or we could have some more custom or advanced uses, some of which bring added complexity, like those of asset management, where the owners know we're BIMing, they know we have data, and they want that information in some form or another. We talked about software. There's a lot of software, and in every session I say BIM is not just Revit. BIM is a process, and Revit is one of the applications that can be used to achieve one or more BIM goals on a project. So the software industry is usually divided into building, civil, and plant, and that's usually because building tools are designed for buildings, replacing walls, floors, roofs, doors, windows, etc. Plant tools are focused on pipes and flow streams and pipe stress analysis and linkages to intelligent schematics. And civil tools are about horizontal infrastructure, terrain, various data layers within the models, and they all come together in some form or another on a project. The trick is to figure out what we're doing, wrap our platform around it, so our CAD tools, whether it's AutoCAD or MicroStation, how we're interacting with our models, Navisworks, Navigator, Solibri, etc. How are we sharing content, our servers, our J drives, project-wise, SharePoint, etc. And what are we doing with the data? All of our standard hardware, and then figure out where is this information going, where else might it be going, and how is it getting there? And what is that mechanism for transfer, and what's the actual particulars of what needs to be transferred? Those are the real important questions when it comes to the delivery of BIM. We talked about collaboration, and that was a pretty intense session. There was a lot packed in there. This is the takeaway. Answer these 4 questions, and you're just rocking when it comes to collaboration. Oftentimes, we struggle on that first question. What are we sharing? Is it CAD? Is it BIM? Is it Revit? Is it Civil 3D? Is it Bentley? Are there non-CAD? Inside or outside IBI? Question number 2 equally compounds the problem. Are we sharing just within our network or with others? And then who's leading it? And then once you have those 3, design the solution, implement, maintain, quality check, and it's kind of like a perfect world after that. But those first 3 questions are oh so critical. The answer might be one office, couple of models, simple sharing, and that's great, but there's going to be far more complex problems. We talked about the BIM execution plan, brought this up quite a bit. We have templates in North America and the UK. We have IBI versions or IBI-ized versions of these templates to apply within the specific regions. They can be formal or informal, but there just has to be a plan. Planning and collaboration, the 2 critical parts of BIM. State your goals. We're doing BIM on a project because we want to make drawings efficiently. That's a simple goal, but it is a BIM goal. Or is there something far more complex? And then we've got to know around that wheel of BIM, what are we going to be using the model for relative to achieving those goals? And then I hear, well, it's just a CAD project. Well, let's make sure that's planned as well. We have to ensure. This execution plan process is supposed to enhance quality. This is the project management triangle. We want to make sure that scope, schedule, budget are in constant alignment with what we're BIMing and why we're BIMing it. We're not going to over BIM, and we don't want to under BIM. We want to do what we're supposed to do to enhance quality and not explode or implode quality. And this diagram we brought up a couple sessions ago. This is fundamentally important for BIM. Oftentimes we jump to step 4 on this, make that BIM execution plan, and away we go. But nobody's asked the owner, are there any requirements, and nobody's assessed the skills of the consultants or the contractors or whoever is responsible for applying the BIM uses to achieve the BIM goals. Answer those questions, develop the BIM plan, and the project can move forward. Okay, so what's followed now, we put out a task force over the last month and a half to collect case studies on where we've done BIM across the globe. So there were a lot of examples. This PowerPoint presentation has a lot of hidden slides as well. I can only show so many in the confines of 1 hour. But it's when you access this presentation, you'll be able to get examples from a lot of the other ones that were exposed. So I'm going to go through buildings, infrastructure and intelligence, and then some non-IBI examples just that I've worked on in the past to outline the scalability of BIM. So the first one, and this is the James Street GO station in Hamilton. It was a Metrolinx project. One thing that was pretty cool about it is that it had this infusion of Revit and Civil 3D simultaneously. So they had to work together. BIM was commenced during design early on, focusing on clash detection, visualization for design understanding, construction design review as the prime goals. But there was also this strong synergy, obviously, between the rail network and the building itself. So there is that dependency on information from the non-building components to ensure that the space itself that the design worked. So when we get into the confines of, why are we BIMing, I like using this one as the first example here because there's so many reasons that you'd want to model, and I want to always step back and say it's not just we have a Revit model, therefore there's BIM occurring, but we're doing Revit because we have to interact with design strategies, with other streams of information. So here's the rail network, pedestrian movement, the bus movement, then the ability for the building itself to wrap over this linear infrastructure and facilitate the means by which it has to satisfy those goals. So I'm going to go through a lot of these in this example. One or two slides per project. This one here is the LaSalle Causeway Bridge in Ottawa. I put it under buildings even though it's civil BIM technically, but a bridge is kind of like a civil building. So the quest here was to actually BIM the existing infrastructure. And I thought, that's always a unique problem because oftentimes we get bogged down with, well, what level of development are we doing? So what's the LOD for the project? When we look at the LOD, something that's already existing, you can get into some extensive details versus a design that we're doing, and we're going to limit ourselves to level of development specific for design. But here, the client said BIM it, Revit was selected, LEAP and Tekla were looked at, and I like saying, they Revited right down to the rivets, and it was quite an impressive model where you can say, yeah, this is a very high LOD, 400 to 500, where it actually represents the entire built form. So this example shows you to what depth you can go to using applications like Revit when trying to BIM something. This would be existing conditions modeling, would kind of be the BIM goal or the BIM use to apply for this type of work. You might step back and say, well, do you really need to BIM to that extent? That's a question to be asked at the project level because the effort to undertake something like this is quite intense. Okay, the Honda plant. This is a project example where IBI has designed over 3 million square feet of assembly plants in Alliston since '86. So there's a lot of history on this type of project. We've started an expansion project, which is the first one to utilize the BIM process for the design. So it's going to be a multi-discipline project. So all of our design disciplines, all in-house. If you look at the BIM uses, the existing conditions modeling is probably one of the uniquest because that's a very hard one to scope. And it does come up a lot, especially in this day and age where brownfield redevelopment is probably more common, especially in the urban environment as opposed to greenfield. So when you're doing existing designs on existing conditions, to what extent do you BIM? How much has to be BIMmed? What are you modeling? What level of development is that existing model? How much detail are you going to get into? And what's the cost of it? How do you price it at your proposal? How do you win the work? And then how do you build a base that's good enough in order to continue the design? So this project is just underway, but I wanted to pose it because, even in my history prior to IBI, this has come up a lot where the client will say, oh, you guys model, that's great. Can you go and, BIM what's out there right now? And it's the hardest question. Do you use point clouds, and then do you interpret point clouds and turn it into a BIM model? Do you just measure? Do you go off of existing drawings? All valid questions that have to be answered when you try to approach a project of this nature. For all of these, if you have subsequent questions, just let me know and I can connect you to the project teams or the regions that have developed these. École Secondaire Catholique in Scarborough, which is here in Toronto, Ontario. Again, it was Revit and Civil 3D together, Revit for the building, Civil 3D for the site. So BIM was done early in the design phases and carried forward. As you can see, the standard BIM goals, but clash detection was included. So automated clash routines were run to an extent. And that's always the thing that I want to qualify with clash detection. It's an admirable BIM goal to say we're going to clash detect on our model, but it takes some diligence to step back and define what needs to be clashed. So is it systems against the building? Are you clashing building against building? Do you want to know if ductwork is going to specifically interact with major structural components? Having that definition enriches your clash detection. So it's not just you press the button and you get those 15,000, 20,000 clashes and you shrug your shoulders and say, well, what was really the point of all of this, right? So having that delineation is so important to make clash detection a reality. And then because the model was there and carried into passed into construction, the wall panel subconsultant was able to actually take the Revit model and panelize it in their version, if you will, of Revit, and that allowed them to enrich the delivery of their shop drawing and their output back to us. And they added here cost estimating as a bonus BIM goal, and that's one of those, as long as it's scoped properly. I'll always say it's hard to model unintelligently than it is to model intelligently, so that if there is diligence relative to how your BIM models are built, you could quantify components to support your cost estimating, for example. If you have faith in the model, and if that's partly in your scope, and if you're not incurring additional liability, as mentioned during the legal session we had earlier. Confidential project, for those who've worked on it, you know what it is. The reason I want to show this is, the model was carried from schematic design forward. The MEP disciplines were able to harness Revit to model their components to keep them concealed. It's a heritage building, so there had to be concealing of components, and the complexity of the shapes is why I put this on here. Because often when you get to curves in multiple directions, some modelers have a challenge in Revit in order to achieve this. But this example here, we had multifaceted and multi-curved architecture that was built carefully in Revit, but fully within the Revit environment. So if you have project examples like this, let me know. We can definitely connect you with some tips and tricks on how to do this. Edmonton Police Campus. So again, we're still in the building sector. We're just trying to span through the region, the globe here. Multiple disciplines, merging models on top of each other, linking them to identify conflicts, so live in the Revit environment. This was a joint venture with TPL, so there was that added aspect of collaborating with an external entity. Nothing like SharePoint or ProjectWise was used, but there was just a coordinated effort to perform a model exchange between TPL Architects and IBI Group. So there was also here the complexity and shape with the curvature. That pushed the team, especially the facade design, towards Revit due to just, if you could just imagine the complexity of trying to truly do that in a 2D environment. Oftentimes, I think I saw on LinkedIn recently, the way the industry is with design has changed because you compare how things were in 2D to how we work in 3D or how we work applying BIM, and we're able to do things better or just do things that we couldn't do in the past with tools like this. So also the Revit models were handed over to the contractor. So there is, again, that question of ensuring that there's liability, there's an understanding of liability, an understanding of purposeful models for design, and risks on the contractor's end to carry them through during construction. And when that comfort level is built, digital turnover can be facilitated. Parq Casino in BC, Vancouver, BC, Canada. Again, similar in concept, some complex geometry, structural models linked, overlaid with architectural models to ensure that there is that synergy and lack of conflicts between the disciplines. Mechanical was able to harness the models and model around the buildings accordingly. Here it was with external entities and the architects were internal, so there is that coordination with sub-consultants. There was a sharing of model with the contractor and sent to the subs for clash detection and comparison and ensuring there's that synergy of design. And the feedback from the client and the contractor, that's something I wanted to highlight. We talk a lot about a BIM goal of design review, and we call it visualization, and automatically people might automatically assume visualization goes straight to renderings, animations, and high-end viz. But visualization also touches upon simply one's ability to visualize. So it seems silly to say that, but to pull up something in a 3D model for a client who struggles to read plans and sections and elevations is still a critical differentiator from the client's perspective, and owners are growing to expect this. So they want to look at our designs early on in the process and understand. They want to get it. They don't want to struggle through drawings and then detriment the design when it's either prior to tender or even worse when it starts to get built. So that's a huge, huge benefit to ensure client, contract, and consultant team are all actually on the same page when it comes to how these designs are going to look. Optegra in central London, UK. So this was from the Brighton offices. It's one of their first use of Revit. So the client, the client asked them to go and, again, BIM an inside compact existing space. They initially did a point cloud, and they have a lessons learned, be mindful of the cost and the effort, not only to generate the point clouds, but also to interpret and apply it. So make sure their feedback is make sure it's stripped out prior to the point cloud, which is very valid. You don't want to do a point cloud and pay for the interpretation and the BIMing of the point cloud, if you will, only for the components to half the components to be gone. The shell was retrofitted to become a state-of-the-art eye hospital, and the architectural team, again, the concept of visualization, they were able to analyze different patient room types to understand and explore design options, as well as communicate with the client of what can work best within the confines of the existing space to benefit the fit out. UTC at Media City, UK, in Manchester. Again, it was a multidisciplined BIM project. The engineering disciplines were external to IBI, so there was that collaborative effort to ensure model sharing could occur, all modeling within the Revit environment, so they were able to achieve design reviewing, clash detection, etc., in the Revit world. They explored the use of Sefaria, which is an analytical application focused on energy analysis mostly. And they were trying to understand at an early stage the annual energy consumption. Now, for those, it sounds like a great idea, which it is. Again, it goes back to be mindful of what you're BIMing and why you're BIMing it. So there had to have been a purpose and a defined reason to do this. And as design professionals, we have to make sure that we're not, approximate is, I think, the most important word right there at an early stage. We're not guaranteeing the actual upon completion of the project. There's a very critical importance there to make sure. And they used an online collaboration tool in the UK called LiveLink that allowed the constructors to share information, content, and actually then track revisions, comments, changes, etc., to the information in order to facilitate supply chain pricing. So that's a pretty cool thing. This was more so for, in the UK, you have work in progress and shared and published, so they're taking the shared and published content, and that should be similar for all collaboration, but they're taking shared and published and analyzing that in order to facilitate downstream knowledge use. Okay, the CSULA Science Laboratory in LA. This was a project that was initially designed in AutoCAD and then modeled in Revit to achieve the stated BIM goals. And the construction verification as a goal was very interesting because they wanted to ensure that, that the project worked. And they were able to identify clashes upon completion of design prior to sending into construction. That saved, you could imagine saving it all in the virtual world as opposed to trying to address them during construction. So they used Navisworks here to review any automated clashes that were detected, and they were able to expose the design issues at that crux or at that cusp between design and construction, as I said, versus doing it within the built world. And then they used the model as well for shop drawing coordination. So they were able to infuse shop drawing information back into the model as it was being shared throughout the construction process. So it's interesting, and I've seen several examples in my past of AutoCAD projects being BIMmed to verify the extent or the accuracy. High School 12 in Cypress, Texas, US. Revit and AutoCAD were both at play here. So we'll have a lot of projects like that as well, where, you know, not all the projects are being done using a BIM application. Some we'll have a fusion of Revit for some or all of the disciplines, yet you might still have 2D information that needs to be shared and understood as well. So Revit began, it says around, like, you know, the middle to the end of schematic, and now it's in construction. The BIM goals, again, they approached your standard, do your design, build your contract documents, use base visualization to understand what you're seeing, and then focused on clash detection as well. They did have 4 models, and those models were shared with not only with the consultant, but with multiple office internal to IBI. So at that point, they were working through best means both internally and externally to share our Revit information and ensure BIM collaboration was occurring. So that's always the question that goes back to that slide. What are you sharing and who are you sharing it with? Got to answer those questions so that the solution can be derived and achieved around how to actually facilitate the sharing that's needed. Okay, and we're going to shift to infrastructure now, but for those who actually go and grab this presentation online, I think there was about 12 other building examples in there that are just hidden slides, so that could have taken the whole hour, obviously. In the world of infrastructure, it's a little different. A former colleague of mine once called it turning BIM on its side. So think of it from that perspective. Whatever we do with buildings, we're going to do with linear as well. This first project, this is the one I assembled this slide last year, King Street Streetscape in Kitchener, Ontario. Small project, 10 million capital cost. The municipality developed what they called a BIM ecosystem to look at specific assets and understand what happens to them when you go through that cycle. You verify what's in the field, you assemble the data you need, you do a design, you approve, construct and inspect, then you want to post-verify that it's there, and then have as-built record information. And the model itself, using a 3D model, it's a 3D representation of the assets as they exist on site. So the assets are in 3D, but then the base may or may not be in 3D. So you have this kind of fusion of 2D versus 3D work with intelligent information attached to those specific assets. Now, in the linear world, you know, your assets are not similar to a building as a whole, but if you look around your building, you start to think in the world of asset management, as we discussed, maybe, goodness, now that's 4 sessions ago. You know, in a building, you could see tables and chairs and electronics and fans and lights and security sensors, sprinkler heads, window shades, anything of that, electronic monitors. Those are all assets that exist within the building. And if you imagine in the life cycle of a building, the assets will become the dynamic element that will shift and move and adjust and be redesigned. May involve building redesign, but oftentimes it'll be asset redesign. And that was the issue here. The model can then be used as a base of a visualization to allow understanding of what the new assets will look like in site, and also provide a basis for linkage to an asset management system. Eglinton LRT, so many on this call are probably on this project. 5.5 billion transit, 15 stations, stops, elevated and buried infrastructure. All good. Here's where we get kind of intense. So 2 design partners, 13 external subs, all working collaboratively on the project. The images on the right are ones that have been developed by the IBI Viz group. These were from the pursuit stage. It's a P3 project, so there is design, construction, and operation working in parallel as a collective whole. We set BIM goals for design, so your standard ones, drawing, schedule, production, design review, and visualization. And we know in parallel, and this is the hard part with the P3, in parallel to our design progressing, the contracting entity is taking our models and applying the BIM goals they're trying to achieve, including schedule, simulation, cost estimating, which is kind of like your standard contractor, but they're trying to develop work packages as well as design temporary works around progressively changing design models. So it's quite a synergy there. So the content split into building and civil, or if you will, vertical and linear infrastructure. Complexity with this client. It's a Bentley client, so we're using Bentley civil tools for the linear, and we're using Revit for the buildings and infusing them together. We're using both Bentley's Navigator and Autodesk Navisworks for design review as well. So there's a lot of tools at play here. Content's being collaborated on Bentley's ProjectWise, hosted by an external entity. So we're tapping into our JV partner's ProjectWise system, and we're working live off of that system to share and collaborate both CAD content, BIM content, as well as Office documentation. This is just a snap of the Navisworks model just to show you the extent. So this is just one of the stations where you've got above ground, below ground, and linkage to the linear infrastructure. As you can see in the bottom right, you've got the tracks going in, but you can see all of the mechanical and electrical as well. So the piping, the conduits, fixtures are going to be modeled. So it truly is as much multidiscipline as we can achieve, both spanning from a building network into and linking into the geospatial portion of the linear. And this is just a snap from the Navigator. One of the hard parts with projects like this one was to actually geospatially coordinate the information. So with every single station, there was a development of control points that aligned it to the overall civil base mapping that laid out the rail network, the rail control points, and there's that synergy back and forth between the Revit building model and the overall civil site rail model, if you will. I'm not going to dwell on this at all because this could be an hour one right here, but this was just one of the many workflows that were developed in order to let the project achieve its CAD deliverable. So we focused a lot about BIM on these previous examples, but this one here, just want to remind that often these BIM projects, so oftentimes a client will say, and this client said specifically, I don't care what's under the hood, I want you to deliver me my MicroStation files as per my explicit CAD standards, period. So they didn't care if we used Revit, EcoSim, Graphisoft, Inroads, they just didn't care. They wanted their deliverable. So this workflow is designed specifically for the Revit world to get our content developed in Revit and then converted to MicroStation and delivered to the client. This would be an effort of the project BIM lead and their team to kind of pull that together. So and then I said here, aside from the contractual deliverables, this is the dynamic nature that you'll probably see if you're on a P3 project, is the contractor is pulling the information and developing their items in parallel. So there has to be that understanding, and you think about the risk there when we say, should we turn our Revit models over to contractors at the end of design? Well, how about turning Revit models over to contractors while we're designing on a daily basis, on an hourly basis, if you will? So that last bullet there, just to make awareness, because we're using ProjectWise, we're actually able to automate a turnover mechanism, if you will. So essentially, everybody works all day long, and then the system goes, sees what's changed, and delivers it to the contractor. So every single morning, the contractor gets an updated version of all of the CAD files, all of the BIM, everything. And that it's alleviated us from that, but it built in the liability now, I don't know if that's the right word, but it built in the requirement for us to now be cognizant of the fact that they have all of the current content, whether it's in design, whether it's decided upon, whether it's rubbish and you're in the middle of redesigning it, it just doesn't matter. The other major infrastructure project, Viva H2 in Vaughan, Ontario, I wanted to just talk about this one quickly. 3 main design partners. The P3 project, there's multiple stops along the way. It's divided into an east and west corridor. It's all civil. There are some of the superstructure for the stops are being designed using the Revit model, but all of the coordination is, as you can see here, it's all the underground. So everything that's going to interact with the buried utilities, drainage, etc., is all what's being analyzed, clash detected, designed, quantified, etc. The building portion, if you will, is a superstructure, and it doesn't really have any potential effect other than its foundations, which are critical in this clash procedure. This project just recently won the General Contractors Award at the Canada BIM Council. So this was as of a couple of weeks ago now. So it was presented by our client, who's Elliston Construction, and they won the award, and the award was based on advanced use of BIM for coordination purposes along a linear infrastructure. So that's, I think, kudos to our team for being a part of this extended team to win that. It also had an enhanced design requirement where where the official design submission could be augmented if we proved we were using advanced capabilities to ensure design coordination, thereby increasing the quality of our 90% deliverable. So that's gone through its processes, and it's under review now by our clients. But it's unique in that, you know, oftentimes when we're in the buildings world, you may have, you know, all of your disciplines are in Revit, and you may have a site to interact with. In projects like this, you can see there's a little bit of everything on the works. There's a lot of tools. Then the submissions had a lot of formats that had to come together. All has to be managed and coordinated at the project level to ensure that what you see in this screen can be authored by the model element authors, so they know what they're authoring, why they're authoring it, the right level of development, and the right amount of detail, as well as to ensure that, as you can see some of the spaghetti there, that things are not interfering with each other. It also used ProjectWise for live collaboration, so with AutoCAD and Civil 3D files. It had a complex Civil 3D data shortcut, so if you're familiar with Civil 3D, a data shortcut allows you to share, so I define an alignment or I define a pipe network, so I'll define it once, and that definition can be used on every single project, or every single file within the project. So that grew quite immensely, but we also were sharing between multiple offices in Canada and our offices in India, as well as the 5 external entities, sorry. So there was a lot happening on this project. And you know, the enhanced design submission, it's one of the biggest benefits that they were able to realize, to show that we had sharing, single source of truth, live collaboration, and a coordinated design. And we had a connected team, and that was a big thing. We were able to onboard new users quite quickly when we were working through this project. Okay, just doing a time check. So then the next 3 projects are from the intelligence sector, and the focus here for these, and this is really in continuation of the asset management discussion we've had previously, these aren't about how we modeled, it's about what we're doing with the information. So in the UK, Highways England, for Highways England, we've developed a tool called Route Mapper Avis, and its mission has been to catalog assets along 16,000 kilometers of roadway. So the focus is on the management of specific assets throughout their life cycle, and the asset lists were designed by the client. So the client has listed what we have to track. How the model is created is really not relevant at all. So we harness GIS tools, so we can bring in CAD data, we can bring in any BIM model that might exist from any source, geospatially located, and there's a representation of the location. More importantly is, what are we doing with those assets? So there's 64 types of assets along 16,000 kilometers of road, and we're able to go and condition assess the assets, take digital photography, point cloud or LiDAR scan them to understand current existing conditions, both as you see them and as you track them with the point cloud, and to geospatially locate them together. And then we've built a system where we can bring all of this information together, complete with the asset data, and we allow Highway England to click on one of their, so to click on an asset type, so one of the 64, click on one of the assets specifically, and it shows it in context, visually, point cloud, and where it is geospatially located across the network. So that's that example in the first slide. You have an element, it's part of a structure, it's on a road network, etc. This route map reviewer kind of pulls it all together. And this is a service we offer to a client, and we're there managing information throughout the life cycle of the assets long past design. Arch Control is a similar product that we've designed in Canada West, and this is used really in our land development practice to have an online repository to manage the architectural material information when we're building out subdivisions. So it can take in the CAD information, build in that layout, and start to track what's happening to each one of the parcels. It tracks the information or the delivery of materials. It tracks warranties, when they're brought, what's on hold, what's been damaged, what has to be returned, and it gives a customizable system that the viewers can then access, query the information, see it in sight, understand the ramifications, and plan capital or operational expenditures throughout the life cycle of the subdivision development prior to turnover of a parcel to an eventual owner or user. And the last one I wanted to show here, it's currently called MIMS, Maintenance and Inventory Management System. It's developed within IBI Group down in Florida for the Department of Transportation. It's an asset tracking system that you can, anything along a linear or vertical infrastructure, you can track the information, add really any type of metadata that's desired, but included in this is a ticketing system. So the next session, we're going to talk a little bit about social information and how you can start to interact with the user. This is starting that premise where I can now go in the assets and the user, can interact and add to the asset-specific data, which can then allow me to visualize where is the asset in sight, whether it's on a building, whether it's on a linear corridor, so I can see it in a BIM model, I can see it in the GIS model, I can see all of the associated information to that very specific asset, and I can now add to it. So I can start to track the history of user interaction, failures, or changes that are required or that have been required to then inform subsequent design, developments, retrofits, etc., on either the success of that specific asset, the failure, and maybe start to direct change of that asset throughout its life cycle or subsequent future life cycles. So some very powerful things from the BIM world there, and the fact that this tool can fuse together information that's hosted from CAD, BIM, or GIS makes it quite a powerful arsenal to have in our tools. Globally, we're working on something called asset management as a service, and it's harnessing this system in order to build that fusion between BIM data and asset-specific data. So if you've never heard of these, just be aware that they're there, and there's a lot of potential for their use. And then you can report on, what type of assets do I have in existence in my defined project or in a defined facility or along a specific area of a corridor, etc. And it'll show you assets and whether they're new, in use, available. You can have whether they're damaged, whatever metadata you add to the system, it will then reflect in the reports that you can generate. Okay, so we're actually doing good on time. I wanted to give the last 10 minutes just on some non-IBI examples that I wanted to just expose. So I talked a lot about the scalability of BIM, and I've done two very, very small projects, one being a porch renovation. And this one here, I wanted to show it first off because it doesn't use Revit, it uses EcoSim. So it's using the Bentley platform. It was a quick design showing what has to be removed in red, and we were able to quickly quantify the volume of removal to help the owner size the disposal box. Quick design of the new, give some quick, simple visualization. And you can see here from the model, I went and I only modeled the front facade, right? We knew the work was localized on the porch, so we didn't go ahead and design or model the entire existing house. It wasn't required. So existing conditions modeling at a very small scale model, just what needed to be there. The new modeling allowed us to quantify volume of concrete, quantify length of handrail to help inform what had to be purchased, which was, it's pretty rudimentary if you think about it, but in order to design or convey the idea, in order to convey what had to be purchased, what had to be disposed of, what easier way is there than just quickly BIMing something like this? And I'll say with the way the tools are today, something like that is very quick and easy and far quicker than trying to do anything like that in 2D. The other one was a kitchen design that I did in the past, and I'm showing this just because, again, it's the scalability. It's such a small scale item, you would think, would you actually BIM a kitchen? And why not, right? We've got the tools, we've got the capabilities. So existing conditions modeling, those translucent walls, that's the bounding wall of the kitchen. Everything inside was part of the design. Quickly cut up the model to get some plans and elevations, a couple of quick views, testing with some material to get the owner to understand what we were doing and why we were doing it. The owner didn't get the, the relationship of the upper cabinets to the lower cabinets, so the model along with the plans was all to really help with the visualization as well. And we were able to procure some direct components, so drawing straight to a stainless steel fabricator just to do a quick cut of high gauge stainless steel to put around the stove. As well, some quick quantities. You have the model, and this is where I cringe to say you press a couple of buttons and you get an output like this. But if you do the model correctly, and by correctly, it's just use the tool as it's designed to be used, you can get a quick count of cabinets, you can get a quick count of area of your floor for your tiles, area of your wall tiles for the backsplash, area of a stainless steel. So you can designate your various finishes, and everything just can come out of the model to support estimation. And then the owner was able to do a comparison on what was estimated versus the differential in their cost, and they had a $3,000 differential because they chose a more expensive material for one of the finishes. And that was it. And there's that clarity there around they knew what they were doing, they were cognizant of their change, and they had an understanding of the result as it was going to come. So quick, simple, very small scale, but as much BIM as what I'm about to show here. So this was a project I did when I worked at CH2M Hill. It's all open availability. This is a winner of the Bentley Be Inspired Award from 2013. So these are all exposed on their website. So that's why I'm just showing this to you quickly. This is one of those 60-plus-year-old existing building, BIM my existing. So we had to go around the site, understand what we were BIMing and why we were going to BIM, and then figure out what had to be done for the new, as well as link to an FM system. So there was a lot to this. I'm showing this because also it's a plant example and the item of intelligent P&IDs. So process and instrumentation diagrams drive heavy industrial work. So we had to pull that information together, and an example there is you might say, you have a pipeline that might go from a filter through a valve, through a pump, to a tank. Now, you'll probably somewhere in the model have those 4 elements, but along the way of that diagram, there could be instruments and other items that you'll never model because they're so small scale, but they're intense. The other thing this project had that was quite complex was a multitude of insane tools. So it did have ProjectWise as its sharing mechanism. We had inroads, Bentley's inroads being used for site, Bentley's EcoSim being used for the building, and they were able to talk to each other through a direct reference. MicroStation was the deliverable, and we had a direct output. We then had a whole host of plant tools. So we had Plant Space, which is a Bentley application that has a backbone database. It sort of talked to the other things, and it output to MicroStation. We had OpenPlant for intelligent schematics. So in IBI, we've actually reviewed OpenPlant as one of the possible plant-based tools. It has a linkage to the piping software as well as output to MicroStation. And then there was a tool called Bentley's Raceway and Cable Management, and that was to build cable trays and to fill the cable trays with conduits and piping spanned across the plant. And it too had an output. So you can see the complexity here. We then, in a deliverable, they wanted AutoCAD and MicroStation files. So we had to deliver both. We had to review in Navigator and in Adobe 3D PDF. And then we had to work with a subconsultant that used Civil 3D. So you could imagine, and I love this because it's the spaghetti diagram of a possible insanity of software, but it can all come together. So on projects where you're working with just Revit or just Civil 3D, smile, because you could work on a project like this at some point, and this is complex. So the collaboration system kind of pulled all this together. You can see there was no Revit, so there was no complexity with sharing a Revit Central model, so I guess that was a good thing here. But there were multiple facilities, multiple offices, external entities, 15 gig of information, and it was just management of all of this information to and from the multiple offices as well as to the client. A bunch of BIM goals, again, your standard BIM goals, right? Drawings, visualization, constructability review. We ran clashes, and there was the added piece of operations and asset management, which I'll touch on in a moment. But the clashes, very similar to what you'd get with Revit and Navisworks. This was EcoSim, the Bentley apps and Navigator, just identifies items that were in conflict, and we had to deliver that, mitigate why these were in conflict, and assign who's going to deal with the clash, what the resolution was, and when they were resolved. The delivery of the 3D PDF was interesting because we actually had to deliver a drawing with the model embedded within it. So this was part of the existing condition assessment. So when you're exposed to that, and that's any brownfield or any project with an existing building or an existing complex, we need to get up front at the beginning and ask, what do they expect? Because this one was unique. They said, we want you to model, and we want drawings of the model. And we didn't know what they meant initially, but they literally wanted drawings of the model. So we took strategically placed 3D PDFs, inserted them into the project's border, and when we delivered those drawings as 3D PDFs, they were able to interact with those strategically located places. And you can move around in the drawing and everything, but it always had that view as a starting point, and they could go and print it if they needed to. But I thought that was an interesting way to show the digital drawing of an existing plant or an existing condition, where previously there was only 60 years worth of paper. The other thing, and why this won the award, is we actually took asset information. So each one of these pumps were identified as an important asset. They had unique numbering, and they had linkages to the owner's asset management system. So this is their operational screen. You can see those same 3 pumps. So we actually built linkages from the BIM model itself. So from a well, I guess it would say a published BIM model. So not the raw authored, but a static snapshot published for consumption by the owner, linked it to the operational screens where the specific assets would appear, and then from the operational screens linked what those pumps controlled to where those appeared inside the model. So we were able to build cycles of links from BIM model to operational screen to O&M or operation and maintenance manual, and then back again to more information. And the beauty of that is, and you can see from that previous screen, one thing controls something else. Even think of in a building for building automation systems, something in the basement or in the lower level will control something on a higher level, but in a schematic, it's just A controls B. But here we were able to build that linkage so it's for visual understanding of what's controlling what and where it is throughout the project. So, the outcome as we presented it was, data validation, consistency of standards, etc. But really it was why I like this example, the synergy between building, civil, and plant. You can have projects with all three facets of those softwares, and the linking to an FM system in an interactive manner, allowing the BIM model to be kind of like that linking or hyperlinking catalyst between the various pieces. And again, when you open up this presentation, press those links at the start of this project, and we have a full video of one I delivered when it won the award at the Bentley conference. So with that, I am actually on time, which I didn't expect, which is good. So we have 2 more sessions that will come following this one. The invite for the future of BIM will look at aspects of BIM standardization, national or government BIM workflows that are either being implemented across Europe or being considered here in North America, as well as concepts of asset management, but furthering that into cognitive BIM and social-based interaction of our data. And with that, I'll just pop open the question pane here. If there are any questions, please enter them in the question pane. And while I wait for those, I'll just let me just come out of this presentation here. And you can see here, for those, if you go and download the presentation, there's a whole host of hidden slides here. Again, it could have been another half an hour. So there's a lot of examples. If you're here and you work on proposals and you're interested in seeing more building examples, definitely feel free to pull down this presentation. It'll be available in the thank you message from the webinar. Okay, so if there's no questions, that's awesome. Please make sure to also enter in your AIA number and your AIBC number. And if that's everything, I will thank you all for attending, and hopefully you're able to call into the next session. Just give it a couple more seconds here to see if any questions appear. You guys are going to let me off the hook today. That's great. Okay, well, thank you everybody, and have a great day. Bye. No question. Geez, Galahar.
Oh, I was holding it in for 20 minutes.